So we are looking right now at the rational functions quiz review classwork, and then you'll have one for homework. Okay? This is very similar to what you did on your quiz last week. The big difference is we're adding the oblique asymptote to the end, OA. Okay, so let's talk about each one. So the first thing I noticed for this, I'm going to zoom in a little bit. First thing I noticed for this is the bottom is not factored all the way. So I'm going to factor it out. I've got x minus 4 times x plus 2 on the top. And on the bottom, gentlemen, on the bottom, what can I factor it for? Okay, so I like to make my box a lot of times with factoring. So this is x squared, this is negative 6. We've got x and x. What two numbers multiply to give us negative 6? Negative 3 and 2 is what we want to use because this becomes negative 3x. Positive 2x, if we add these together, we get negative 1x. Okay? So this is x minus 3 and x plus 2. Right here, the first thing I'm going to look at is I can remove this. This is removable discontinuity, right? So I'm going to go all the way down to removable discontinuity, and I'm going to put negative 2, the opposite of what this is. Jordan, do you need to move your seat?
Yes. I got to give you I can't see. No, I'm trying to look up this. You know what I'm saying?
Okay. All right. Now we're going to go back up to the zeros. Remember, I don't want to use that removable discontinuity anymore. What is the zeros for here?
Where?
Number 1. It's positive 4, yes. Okay? It is positive 4. It's the opposite of the top. What's my vertical asymptote? X equals 3. Make sure vertical asymptote is a line, so I need to make sure I have the x equals part of it. Okay? Horizontal asymptote. So I'm going to look up on the board again. I'm going to write this right here on the top so that I remember. Horizontal asymptote, we have the degree of the numerator is bigger than the denominator. It's y equals 0. If the numerator is equal to the degrees on the denominator, it's the leading coefficient. And if the numerator is smaller than the denominator, there is no horizontal asymptote. None. Okay? All right. So is the top and bottom, is the numerator bigger to the degrees? So that's the little exponents. Are they equal to, greater than, less than, what? Equal to. So that means it's the leading coefficient. Are there any numbers in front? So then it would be y equals 1. And you need to have that y equals for these. Y equals the leading coefficient, y equals 0 or none. All right, end behavior we know is always x approaches infinity, y approaches something. X approaches negative infinity, y approaches something. What are these both going to be approaching? 1. Same as the horizontal asymptote. Okay. Discontinuity is what again? Vertical and the removable. Yeah. So the discontinuity is 3 and negative 2. Okay. Now this is when we get to the new stuff. We've got our oblique asymptote. So the first thing I'm going to do is I want them in standard form, not factored form. So I'm going to multiply these two things together. So I'm going to end up with x squared minus 2x minus 8. All right? If you want to do the box for this, that's fine too. You can do x minus 4, x plus 2. We get x squared, 2x, negative 4x, negative 8. These two added together gives us negative 2. Okay, now I want to see if they go into each other. So if I've got x squared minus x minus 6, I take the bottom, divided by the top. X squared minus 2x minus 8. What times what gives us x squared?
X.
X times x squared would give me x to the third. 1. Oh, so it doesn't really have an oblique asymptote, right? Because they're going to be the same. So my oblique asymptote is none. Okay? Don't really have one. let's go to number 2. Okay. So number 2's got this really complicated top. It's got x to the third plus 5x squared minus 32x minus 7. This doesn't even, all of these don't even have anything in common, right? So does it have any zeros? No. What's my vertical asymptote? Not x, but, oh, you're right, x equals 4. You're good. My horizontal asymptote. Okay, so if I'm looking at my numerator and denominator, my numerator is definitely bigger. So if my numerator is bigger, okay, these are wrong, by the way. This goes this way. This goes this way. Sorry. Okay, if my numerator is bigger than my denominator, then there is no horizontal asymptote. None. None. Okay. End behavior. As x is approaching infinity, what's y approaching? As x is approaching negative infinity, what's y approaching? Okay. So as x gets bigger and bigger and bigger, what is this going to be approaching? Infinity. And as x is approaching negative infinity, what's y approaching? Negative infinity. Is there any removable discontinuity? None. And what's my discontinuity? 4. Okay, now I have to do my oblique asymptote. So I've got x to the third plus 5x squared minus 32x minus 7. And I've got x minus 4. What times x gives me x to the third? Good. X squared times x gives me x to the third. Remember, we have to times them by both each time. X squared times negative 4 is negative 4x squared. I change my signs. I add straight down. I'm going to get 9x squared. Is everybody following so far? Am I going too fast? We're okay? Okay. What times x gives me 9x squared? 9x. 9 times x, 9x times x gives me 9x squared. Make sure you pull down this negative 32x and this negative 7. I forgot that part. Make sure you pull that down. Okay. 9x times x gives me 9x squared. 9x now times negative 4 gives me negative 36x. Now I'm going to change my signs, and I'm going to add straight down. I'm going to get 4x, and I bring down that negative 7. X times what gives me 4x? 4. So I'm going to go 4 times x gives me 4x. 4 times negative 4 gives me negative 16. Just ignore them then. It was just to help you. Then I'm going to change my signs and go down. So 16 and negative 7 gives us 9, right? But we don't need to worry about a remainder, right? We just say y equals x squared plus 9x plus 4. That's my oblique asymptote, and I'm done. Because x times nothing will give me just 9. Okay, these last two. We are going to make an equation given this information. Okay? Vertical asymptote, a rational function with vertical asymptotes at x equals 5 and x equals 0. Zeros at 6 and 9. And a horizontal asymptote of y equals 5/3. Vertical asymptotes go on what of the function? If I'm going to say f of x equals, and I'm going to have a line, where do I put the vertical asymptotes? On the bottom. And remember, they're the opposite of these, right? So it'd be x minus 5. How do I put 0 down here? It's just an x. It's just an x. Because remember, if I put a 0 in for that, the whole bottom part would be 0, right? Okay, zeros go on where? The top or the bottom, or what are they? Top. So remember, they're the opposite. X minus 6, x minus 9. Okay, and it says it has a horizontal asymptote of 5/3. That must mean that it has the same number of x's on the top and the bottom. Is that true? Do they have the same number of x's? X and x, x, x. You know, the same number of exponents? Okay, then we just put the 5/3 in front. And we're done. That's our answer. Okay, on the quiz, you would get a point for having your vertical asymptotes, a point for having your zeros, and a point for having all the horizontal asymptotes. So that'd be worth 3 points. Okay? All right. Let's look at the next one. Okay. We ready, gentlemen in the back? Shh. Okay. You have a rational function with removable discontinuity at x equals 3 and negative 4. Zeros at 2, negative 5, and negative 3. Vertical asymptotes at 6 and 5, and it has an oblique asymptote. If it has an oblique asymptote, it means the bottom's got to be bigger than the top. Okay, so first of all, we're going to have f of x equals, okay, removable discontinuity. That means it has to be where? What has to be where? Top and bottom. So remember, it's the opposite of these. So we have x minus 3 on the top and the bottom. We have x minus 4, so that becomes x plus 4 on the top and the bottom. Okay, that covers our removable discontinuity. Zeros, they go where again? Top or bottom? Top. So they're the opposite of those. So we've got x minus 2, x plus 5, and x plus 3. So I covered those. Vertical asymptotes at 6 and 5. So those go on the bottom. X minus 6, x minus 5. Okay? Now, it says we have an oblique asymptote. So let's check. How many exponents do we have on the top? We've got 1, 2, 3, 4, 5. And 1, 2, 3, 4 on the bottom. So we're going to be able to divide this to get an oblique asymptote. So we're good. Questions about any of this? Okay, you ready for your homework?